Okay, that's a pretty rockin' R value, right? 0.8, let's say 0.836. R of 0.836 indicates that there is a pretty strong, wouldn't you say? Pretty strong what?
Linear relationship.
Sorry?
Linear relationship.
Linear relationship? What kind of linear relationship? Positive. Excellent. There's a pretty strong positive linear relationship between what?
Between chirps and the cricket.
Between chirps and temperature. Yeah, everything back to the problem.
How does that indicate that?
Okay, remember the R value is the one where I drew, it strength on the ends and then worse towards 0. So the closer R is to +1, the better the positive linear relationship. The closer it is to -1, the stronger the negative linear relationship. So that would be where the dots are lining up, you know, kind of in that fashion. And closer to 0 means what?
Linear relationship.
Yeah, the worse the linear relationship. Okay, so 0.836 we like, very good. And since we decided that all systems go, right, now we can describe the relationship with what? What describes that relationship mathematically? The line, excellent. The equation of the line, good, good, good. So the equation of the line here, it's y hat, right, equals, and we take it right off our screen, ax plus b, so a is, let's say, 3.24, x, plus 26.01. Whoops. Okay, so the equation of the line describes this phenomenon we're seeing. Okay? Scientific method, gang. Any kind of data or any kind of equations that you use in biology, chemistry, you know, this is where it starts off. Somebody starts with, oh, it looks like this is going on. Then they go collect data and prove it. And then they describe what's going on with math. Okay? So, next step. What does the slope mean? And is the y-intercept applicable here? Can somebody tell me what the slope means? In terms of cricket chirps and temperature? Go ahead, Jennifer. Okay, as crickets chirp more, the temperature increases. Tell me by how many units? The data, you might want to make a note to yourself. The data is in, can you see over here, Joey? Okay, the data is in chirps per second and temperature Fahrenheit. And that's Y. So 3.24 means that when the crickets chirp when the increase is one more chirp per second.
Goes up
The temperature increases by 3.24 degrees Fahrenheit. Write that? Let's say when cricket chirps increase, ran out of room. Temperature increases 3.24 degrees Fahrenheit. Yeah, Mike.
And then for the y-intercept, would that just be, if they're not chirping at all, it's 26.01 degrees?
Yeah, would that make sense?
Frozen.
Does it make sense that when, okay, so Mike's question was, then for the y-intercept, are we saying that when crickets aren't chirping, it's 26.01 degrees Fahrenheit outside? Remember we talked about the extrapolation thing and the realm of data? Do you figure it has to be 26 degrees before they stop chirping altogether? At 26 degrees,
Frozen.
they're dead. They're dead long before 26 degrees.
So it's not
Okay.
applicable.
So it's not applicable in this case. Because crickets can't even live when it's, sure they're not chirping, but they're not even around when it's 26 degrees, okay? So it's in this particular case, it's not applicable because let's say, because 0 cricket chirps are there's gonna be a wide range of temperatures when crickets aren't chirping, right? And that makes sense with respect to our data too, because if it's too warm, they're not going to chirp. At some point, everything's going to get cooked on the other side too, right? And there's only so warm it can physically be outside, right? So we can't just keep going warmer, 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 or colder, 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 because in each extreme, those temperatures don't even support life whatsoever. Yeah.
Does that vary for what kind of situation?
Yes, absolutely, absolutely. Yeah. So the question was, does that depend on the data as to whether or not the y-intercept is applicable? And yeah, definitely. Okay, so did you guys get the information about R down? Let's put the intercept information there. So the y-intercept is not applicable because crickets will stop chirping long before it gets to 26 degrees Fahrenheit. Does that do it for you guys? Is that all right? So by the data, the crickets aren't even chirping until it's in the 70s. 69 degrees, I think, is the closest there, right? So the range of data is the upper 60s to the low 90s. Okay? Does that make sense? Okay, so the next thing we want to do is maybe some, let's graph our line with our scatter plot and then do some estimation. Maybe look at a residual or two. Okay, so you need your output and you need your scatter plot.
I'm only
Yes,
getting
sir?
a straight line. I turned scatter plot on, and assigned it, but I'm only getting a line. I'm not getting
You're not getting your
any dots or.
okay, give me a second, and I'll be right with you. Okay, so you want to go into y equals, and you want to clear out your previous equation. And then you want to go, there's 5, right, enter, graph. There's 5, right, enter, graph. What do we got? Oh, did you get your scatter plot before?
The calculator stuff.
So let's go stat, enter,